Okay, so today I'm going to be doing a micro tutorial on Linux port scanning with the Nmap command line utility. So the first thing y'all are going to need to do is you're going to make sure you have Nmap installed, and to install Nmap you're going to either use apt, portage, pacman, or whatever your package manager is to search for port map to get the correct package name and then install it. So for Debian, it's going to be apt install nmap. For Gentoo, which is what I'm using, is going to be emerge nmap. Enter. So you're just going to make sure you have that command line utility installed, and after you get that done, to scan your local area network. Okay, so let's go ahead and get started here. So I'm going to go ahead and be using the fast mode switch, which is the dash F switch. In fast mode, you're going to be scanning the top 100 most commonly used ports, which is what I usually recommend for doing tech-related stuff when you want to find out some open ports on the router, or if you want to find out an open port for maybe your iDRAC, or and the most commonly used devices like printers and servers and etc. etc. So I'm going to scan my local network. Now to do that, I'm going to type in nmap-f. And I have a custom router IP, so if you're wondering, hey, why is your IP like that? 77.77.77.1, and then I'm going to go through all the IPs. So I'm going to type in 254. So it's my starting address to the ending address on the subnet. And then push enter. And as you can see, these are all the IPs on the network, and these are all the open ports. So that's using fast mode. Okay, so the three most commonly used LAN IP addresses for your starting IP address are going to be 192.168.0.1 or 192.168.1.1 or 10.0.0.1. And that can just be used as some type of basis to go ahead and help y'all get started. So let me show y'all how to do it now with the default mode. The default mode's actually a little easier. You're just not including the dash F switch for fast mode. So it would be nmap, and for my LAN it would be 77.77.77.1 through 254. And this is going to scan the top most 1,000 commonly used ports. So fast mode is for 100. Default mode is for 1,000. The more ports you scan, the longer the scan takes to complete. There are some tricks to do it quicker, like maybe running Nmap in parallel. But for general use case scenarios, this is the way you use the application. As you can see, it's taking quite a bit longer. So it's scanning 10 times more ports on those 255 possible combinations. So it's going to take about 10 times longer. And there you go. Now I have a list of all the open ports. As you can see, the list is virtually the same because I'm not using any proprietary ports that would be included in the default that were not included in the fast mode. So that's why I recommend using fast mode. Now, if you want to catch custom ports, then you're gonna probably have to scan all 65,000+ ports for a single IP address for however many IP addresses you're doing. So unless you're running something like this in parallel, it's going to take you a while. Okay, so I clear the terminal out so y'all can see. So let's say you want to scan a larger subnet. So in most use case scenarios, you can do nmap -f 7777777.1 through 254, which is what is an example I showed you with my local area network starting IP address. And this is generally how you use the application or the command line, whatever you want to call it. Now, if you want to scan a larger subnet, you'll notice, hey, how do you do that? So Nmap recognizes the subnet you want to scan in two ways. When you do a dash and 254, what that's saying is for the 255.255.255.0 subnet range, which means it's using all 255.4 combinations where this one is. So it's 1 through 254, or you can do 0 through 254, but I just use 1 as an example. So let's say you want to expand your subnet and you want to scan on an expanded subnet. So if you look back behind the 1, there's 2 7s. So if I was to expand the subnet to 255.255.0.0 on my network, then this subnet mask range would be open as well, the one behind this period. So then your possible IPs go from 255.4 from 255.4 possible IP addresses to 254 times 255.4. So you're roughly scanning around, let's say if you want to scan around all 65,000-ish IP addresses on those two subnets, what you're going to do is type in /16. And then when you do the scan, it's going to scan both these subnet ranges now. But in most use case scenarios, you're never going to have to worry about that unless you're on a really large network that happens to have a larger subnet range. In just about every use case scenario, even the small office networks, what you're going to be running into is you're going to only be running into that end subnet mask. So it's very rare that you see a fully expanded subnet mask, but sometimes you do. So in order to do that, let's say you want to scan both those complete subnets right there, you do a /16. And a lot of people are like, well, what does a /16 mean? Well, I'll show you. So if you go, I'm going to go over to my website here and pull it up. And then I'm going to go over to documents, and I have a nice IP subnet table right here that y'all can look at. So, and it breaks down the subnet range. So the /24 is the one we've been doing when we use the dash and we type the -254. We're scanning all 200. We're scanning all 254 addresses. And if you're not familiar with subnets, you're scanning this complete 0 subnet set. So when you have a 0 right here, it's saying this entire subnet range is open. So that would be a 0 to a 255, but you usually don't use the 255, you usually end at 254. So I'm trying to keep this a micro tutorial, so I'm sorry sometimes I go on explaining stuff. I don't know why I do that. But that's what the /24 means, which is the default subnet range most networks use. So if you're working with an expanded subnet network, you're going to be scanning both of these subnet slots, which would actually be 255 times 255, which would be a total of this many possible IP addresses. And to do that, you'd use a /16. So let's go back to, okay, so back onto the terminal here. So instead of doing the -254, you can just type in 24, and that takes care of the default use subnet range. If you do a /16, it's going to take care of both of those subnet range slots. And there are some pretty good use case scenarios for using an expanded subnet range. Like, for example, if you don't want to mess with setting static IP addresses, but you want to assign kind of like a permanent IP address to each device, you can expand that subnet on your router, and then you can set a ridiculously long DHCP lease time. That way, whenever you plug a new device in the network, it gets the IP address, and you can have and then you can have the IP address lease time be really long, like months or year or something like that. And that kind of allows you to have a static hybrid DHCP network, so you're not actually having to program all the static IP addresses in via MAC address. The DHCP server is taking care of the assignments, and your subnet range is never going to fill up because you're not limited to those 255 addresses on that one subnet. Instead, you expanded, and now you have over 65,000 possible slots. So unless you've plugged in a total of 65,000 different devices, you're never going to have that subnet mask range fill up. Anyway, I'm getting completely off topic. This is a micro tutorial. Y'all understand the dealie. And so a quick example for the dealie here. So I'm going to do nmap-f, so don't wait like an eternity, and then type my LAN IP I want to start from. And instead of typing the -254 to go to that end IP address for the subnet, I'm going to do a 24, which is the same thing as I was explaining the dealie. So, alright, so there you go. It did the same thing as the -254. My goal of making these videos is to help y'all out and save y'all time. So if you like what I do, please like and subscribe to the channel, and maybe support me with a cup of coffee or something like that.